Hello everyone. Our today's topic for the chemistry 9701 A level is Gibbs free energy. Gibbs free energy actually explain the reaction either it is spontaneous or not. Gibbs free energy is represented by G. Delta G means change in Gibbs free energy, and this degree stands for standard states. Now, this side indicates the standard Gibbs free energy change is equal to minus absolute temperature and the total standard entropy change. Total standard entropy change. Now, this can also be derived from the equation of entropy. We have already discussed that the standard entropy change total is equal to the standard entropy change of the system plus standard entropy change of the surrounding. Now, if we put the value of standard entropy change of surrounding, then we will get this equation that standard entropy change total is equal to standard entropy change of the system minus delta H over capital T, enthalpy over absolute temperature. Now, we can also rearrange this equation. We can also rearrange this equation as, if I multiply whole of this equation with minus T, absolute temperature, I will get minus T delta S naught total multiplying. After multiplying with minus T, we will get here minus T delta S naught system, and then on multiplying with minus T, this will become delta H. Now this equation can be written as also minus T delta S naught total is equal to delta H, because it has a positive sign, can be written on left side and can be written this on the right side with negative sign of the system. Now, as we know that minus T delta S naught total is equal to delta G naught. This will becomes equal to delta H naught minus T delta S naught system. Now, this equation can easily be used to calculate the standard Gibbs free energy change for a certain reaction. This equation can be used easily when we know the value of standard enthalpy change of reaction, absolute temperature, and the standard entropy change of the system. If we know all of these values, we can use all these. Now, one thing is important to remember. In case of entropy, if the standard entropy change total is positive, then reaction is feasible or spontaneous. But in case of delta G naught, standard Gibbs free energy change is negative, then reaction will be feasible or spontaneous. Now these values indicate that in case of entropy, positive value indicates the reaction is spontaneous and can be and takes place without any external aid. But in case of Gibbs free energy, if it is negative, then the reaction will be considered as spontaneous or feasible. Now this equation has two parts. This is the first term. This is the second term. If we have entropy always positive, automatically this positive value after multiplication with the negative sign will remain negative, and if this term is much more larger than this, automatically the answer will become delta G negative, and the reaction will become a positive, will become a feasible or spontaneous. But if entropy is negative, then negative value after multiplication with this negative will become positive term, and if this positive term becomes large or small, definitely with the addition with this positive term, the delta G naught total Gibbs free energy change will become positive. That will indicate that the reaction is not feasible. In this case, in this manner, Gibbs free energy can easily explain either the reaction is feasible or not. I thank you all.